Okay, so we're going to start with 17. Again, the test will have word problems exactly like 17 and 18, except the numbers will be slightly different, right? But the concept will be the same. So look at number 17. It says, I decided to use chalkboard paint to create a chalkboard on a door. You want the chalkboard to cover 5 square feet and to have a uniform border. What does that mean, uniform border? Look at the picture. See if you can figure out what it means.
It has to be right.
No. Okay, it means that the border is going to be the same on all sides, right? If you look at the picture, you can see the width of the border on the top is X, and on the right it's X, and the thing's a rectangle, so that means on the left side the border is X, and on the bottom the border is X feet. So uniform means the same all the way around, okay? That is an actual English definition of the word uniform. It's not a math definition, right? It can mean like a suit that you wear for a specific job, but it can also mean all the same.
So I
Right?
thought
Uniform.
of it as a deer, like say they have a good uniform scratch on it.
Now you're using it in a way that I don't know. Find the width of the border to the nearest inch. Okay, so I know the area of the chalkboard. What is the area of the chalkboard?
21.
Think about it. Read the problem. Look at the picture. But it's not in the picture. I don't see anything that shows me the area of the chalkboard. What is it? Somebody said it, but now they're not saying it
I
anymore.
said 5.
5. Yeah, I want the chalkboard to cover 5 square feet. Square feet. Square feet. That's a measurement for area, right? Square feet every time. Area. And that's what square feet looks like. And I know the dimensions of the chalkboard part, but they're going to have X in them. I know the length of the chalkboard, but it's going to have an X in it. Can somebody tell me we'll call it the height so that we're being clear. Can somebody tell me how to express the height of the chalkboard part as an expression with an X in it? It's definitely going to have a 7 in it, you're right. I know the height of the door, and I know what the borders are going to be. It's not 7 times X, no. That would be a really big chalkboard. It would be bigger than the door if it was 7 times X. Okay, let me draw the picture. We need to learn to look at these things and think critically, because this is a problem that state test types love to give, because it just requires, it's not particularly complicated, it just requires you to think critically. If I know that the whole thing is 7 feet, the whole door, actually it's only to here, right? And I know that this little piece right here is X, and this little piece right here is X. Tell me the height of the chalkboard using 7 and X.
There's no split on this.
I know, but it's a uniform border, and I told you that means it's the same all the way around, right? So if it's X at the top and it's uniform, that means this is X, and this is X, and this is X too. That's what uniform means. That's why I talked about that word. Okay, I'll tell you how to do this. You take the total height of the door. Well, I don't want this little piece, and I don't want this little piece. What is the height of this piece? Close. The height of this piece is X. What's the height of this piece that I don't want? X. So I need to subtract out the heights of the pieces I don't want. These are like terms. Is everybody following how I got 7 minus 2x now that you see it? I know that the height of the whole door is 7 feet. And I know if I subtract out the borders, whatever they are, I don't know yet, that's what I'm asked to find, that 7 minus this border will give me just the chalkboard. Is that making sense at all? Okay. So let me make a little note by this. This is the height of chalkboard. Okay, now, those of you, some people didn't answer me when I said, do we understand it? I'm assuming those people don't. So if you were one of the people who said you do understand that, tell me how to express the width of the chalkboard as an expression with an x in it.
Would be
3 minus x.
minus x.
3 minus x minus x, which ends up being
3 minus
minus
2.
So using the same principle we used before, we know that the door is 3 feet across. I just want to know how far across this is. So I need to subtract out this piece and subtract out this piece, but those pieces are x's. So I did 3 minus x and combined the like terms and got 3 minus 2x. Okay, great. Now I should be able to write an equation. Because I know the length, or the height, I have that. I have the width, and I know the area. So what is the formula for area of a rectangle? Really? Are you going to tell me the formula for area of a rectangle? Okay, then hang on a second. I'm going to wait until someone in this room can tell me the formula for area of a rectangle. Yes. You need to know that, guys. That's elementary school. That's an elementary school formula. Area of a rectangle is base times height or length times width. Either way you want to think about it. What was your question?
Since the door is 7 feet and the chalkboard, oh, never mind. I was about to say, since the door is 7 feet and I thought the chalkboard was 5 feet, could you just say that both x equal 1?
Right, but that's not the height, right? It's just the area. Okay, so we know that the area of the chalkboard, so this is the height, this is the width. So the area equals length times width. I'm using length and height in the same way, right? Length and height. So that means I can write the equation. Area, I know. Length slash height, I know. Width, I know. Now I just need to solve this equation for x. So the first thing I would do is I would FOIL. Because we don't have any way to solve the equation for x with it looking like this, right? If it was equal to 0, if the area was 0, then I would be able to. I could set each parentheses equal to 0 and solve, right? Like we were doing it using factor Nick up in your eyes. I'm not that boring. Fairly boring, but not that boring. Okay. 7 times 3 is what?
21.
7 times negative 2x is what?
Negative 14x.
Negative 2x times 3 is what?
Negative 6x.
Negative 2x times negative 2x is what?
4x. Squared. Squared, yeah.
Thank you. 4x squared. That's important. If you were to forget that, the whole problem is shot. Okay, I would combine my like terms, and I'm also going to rearrange it so that it's in descending order. And then if we can't get it from here to the end, you're in deep trouble. I end up with 4x squared minus 20x plus 21, because that was a positive 21, equals 5. I want to know what x is. How can I find x?
Solve by either one of the things we learned.
Yeah, you got options, man, because I don't specify how to do it. Now, factoring may or may not work. Probably not, right? Factoring's not great. It only works if the answers are nice, neat answers, right? And these may or may not be. I don't know, but there are two that always work. I could always do the. What's one that I could definitely use? I could definitely do that. That always works. And what's the other one I can do that always works?
The one where you can use it over 2 or just where you take the problem and put it over.
It has a name. The other thing I'm looking for. There are 3 ways. I just told you factoring's no good. Quadratic formula is good. What's the other way that we talked about? It's literally written on the front page of the test. It's in the instructions.
It is by completing the square.
Yes.
That's what I was trying to talk about.
You guys are in trouble.
Can you solve by completing the square part 2? Is that the one where we did it where we put it over 2?
Over 2. You mean divide by the leading coefficient? Which
Yeah,
is sometimes 2 and sometimes not?
Mm-hmm.
Yeah. Okay. I would probably do quadratic formula. I think it's the easiest. It requires the least amount of thought. But you could definitely do completing the square if you wanted to. There would be 2 different tactics. If I was going to complete the square, I would need to move the 21 over here and divide everything by 4. and I can totally do that. If I'm going to do quadratic formula, which I'm going to do, what do I need to do first?
Get the 5 over.
Good, subtract 5, because in order to use it, I have to have an equals 0. That's the rule with quadratic formula. It has to be, your function has to be equal to 0. And now I'm just going to plug into the quadratic formula. Then there's going to be one little piece at the end that we'll have to talk about. But for the most part, from here to the end, it's just plugging in. So A is 4, and B is negative 20, and C is 16. So I have negative B would be negative negative 20. So that's 20. Plus or minus the square root of negative 20 squared. Minus 4 times A, which is 4, times C, which is 16. All over 2 times A, which is 4. I would simplify the discriminant. And that would be 400 minus 8128. That should be 372. 372? Somebody gonna check me?
144.
You got what?
144.
144. So I did bad math.
Is that the report? No.
I didn't write it.
Oh.
144. What did I mess up? Okay, I'll take your word for it. Okay, now what?
Square root of 144.
Yeah, which is
12.
12. Okay, so now I'm going to get two answers, right? 20 plus 12 over 8, 20 minus 12 over 8. That would be 32 over 8, which would be 4. What are the units that I'm dealing with right now?
Square feet.
That's the area.
Feet squared.
That's the same as square feet.
Yeah, no, I didn't even think that.
Inches.
No, none of these measurements are in inches. I'm dealing in feet. I'm dealing in linear feet, not feet squared, just feet. I didn't hear anybody say feet. Sorry if you said it and I didn't hear you. No, sorry, 12. Okay, so I got two answers. That's weird that I got two answers. Yes?
Square feet.
It is not square feet. We're talking about this x is part of length or width. Length and width are linear measurements. They're just feet, right? The area is in square feet, but this x is not a piece. It's a piece of a linear measurement. So we're talking about just feet at this point. Okay, one of these answers is no good. I have an extraneous solution, which we've talked about before. That means I've got an answer that does not make sense in this problem. So I want you to look at 4 feet and 1 feet as my options. Look at the details of the problem. One of those answers should scream to you as definitely got to be wrong. Yes?
4.
Why is 4 feet wrong?
Because it's over
The width of the door.
Yeah, that would mean that the width of my border is wider than the whole door itself. How would that work? It wouldn't. That's impossible. That can't be done. So this solution is extraneous. It does not work in this problem. I can't have a border that's wider than the whole door. Right? That wouldn't work. So 1 foot has to be right, but that's not my final answer either. What's wrong with it? Read the problem carefully.
Here's the inch.
Say what?
Here's the
Yeah, it wants it in inches. That's in feet. So I can fix it pretty easily, right? How many inches?
inch.
That's the width of the border. If I make a border that's 12 inches wide, all around the door, my chalkboard will have an area of exactly 5 square feet. Yes?
If the thing was 5, if the chalkboard was 5, and since the door is 7, you should just tell the x is 1.
No. No. Because the 5 square feet, you're thinking in terms of linear measurements. You're thinking of 5 as being this. 5 is not the height. 5 is the area of the thing, right? This is coincidence that worked out in the way that you wanted it to work out. It will not do that on the test, I assure you. It just happens to be with these numbers that I chose, it worked out that way. One last little thing I got to show you on this, and I'll take any questions you got, is if this hadn't been nice and neat, 1 feet equals 12 inches, what if I ended up with, something like 0.8 feet for my answer, and I want it converted into inches? How do you convert 0.8 feet into inches? So what? How did I convert 1 foot into 12 inches? What did I do to the 1 to get the 12? Multiply by 12. So if I want to convert 0.8 feet into inches, you multiply by 12. I hope everyone is hearing that, because I'm telling you on the test, it's not going to be a nice, neat 1 foot. Oh, I can just say 1 foot is... You're going to have to know how to convert a fraction of a foot into inches. Did everybody hear what I said on how to do it? Okay. Are there questions about this problem? Because the one on the test is just like it. So if there's parts of this that aren't clear, let's talk about it. Okay, cool. 18. If you change your mind and decide you do have a question about 17 later, you can ask. 18. The ratio of the length to the height of a golden rectangle is 1 plus the square root of 5 to 2. Is everybody familiar with that form of a ratio, the way I have it written there? You should have seen this in a previous math class. Like if you have a colon like that, that means a ratio of 1 to 5. Y'all have seen that before, right? Never seen it. Facepalm. Okay, it's the same as this. It's a ratio, right? 1 to 5. They should have taught this in a middle school math class. Now you've seen it. So, what this is basically saying is that this is the ratio of a golden rectangle. The golden ratio is a pretty cool thing. Stairs that are well built, the run of the step to the rise of the step follows the golden ratio. Nick, stand up. You won't fall asleep standing up. Or if you do, at least I'll get a good laugh out of it. Okay, so the dimensions of the face of the Parthenon in Greece form a golden rectangle. Do y'all know what the Parthenon is? Never seen a picture of the Parthenon before? You probably have. Remind me after the problem, I'll show you a picture of the Parthenon. It's a big Greek building with huge columns in front. Okay? The dimensions of the face form a golden rectangle. The length of the face is 28 meters. What is the height? Does anybody have any idea how I might approach this problem?
Yeah.
Tell me.
It's hard to simplify that one.
Yep. I haven't used this is only part of the information that I was given, so you might need your thing so you can see there's another piece that's missing. So you're going to use a skill to solve this problem that you did not even learn in my class. You've known it so long you learned it in 8th or 7th grade probably. I've got 2 ratios, but I'm missing a piece of one ratio. What can I do to solve for that missing piece of the ratio? I need to set up a proportion. Do you remember proportions? We did them in here. You should have done them in a class before here. Proportion is where you set one ratio equal to another. That means they're proportional. And I can do that here. I know that this is length to height, and the Parthenon has a length of 28 and a mystery height that I need to solve for. Okay, so now we know how to do it, right? Cross multiply. H times 1 plus the square root of 5 equals h times 1 plus the square root of 5. Leave it like that for now. 2 times 28 is 56. Right? Cross multiply. We good on that? I taught that in this class, I know. Okay, I'm trying to solve for h. So what do I need to do to get h by itself? Do what? If I distribute, I'm making my job harder, because right now I've only got one H. If I distribute, I'm gonna have two H's, then how will I get it back? So,
How'd you get 56?
2 times 28, cross multiply. This times this on one side, this times this on the other, right?
Can you subtract the parentheses?
That's not gonna,
Divide.
I wouldn't subtract the parentheses, it's H times the parentheses.
Divide.
Divide by the parentheses. If I divide by 1 plus the square root of 5, won't these cancel and leave me with just H? I'm using the same philosophy I would use if I had this, right? I would divide by 6. I've got the same thing going on here, it's just that I'm multiplying by a binomial instead of a number, right? It's the same idea. Okay, these will cancel. So H equals 56 over 1 plus the square root of 5. Now, I want this answer to be exact on the test, not a decimal. If I wanted a decimal, you can put that in the calculator like that to get the decimal. I want the exact answer. So what do I need to do to simplify this radical expression of that?
One minus the square root.
Good, what is that called? Excellent. Very good, Alex. I need to multiply top and bottom by the conjugate, right? Remember, I told you if you've got a binomial on the bottom with a square root, your brain needs to go immediately to conjugate. It needs to be the cube conjugate. Okay, on the top I would distribute 56 times 1 is 56. 56 times the negative square root of 5 is negative 56 times the square root of 5. Can't multiply those. One's outside the radical and one's inside. Okay, on the bottom, I 40. 1 times 1. 1 times 1 is 1. 1 times the negative square root of 5 is the negative square root of 5. Square root of 5 times 1 is square root of 5. Square root of 5 times the negative square root of 5 is negative square root of 25. Okay, now I'm going to start simplifying. I know that these two definitely cancel. And I know what the square root of 25 is. Square root of 25 is 5. So I ended up with 1 minus 5 on the bottom. I know what that is.
Can I sit down now?
Yeah. It's negative 4, right? 1 minus 5. What else can I do? Good. All of these things are divisible by 4. So I'm just going to do 56 divided by negative 4 and get negative 16, and negative 56 divided by negative 4 and get positive 16. Square root of 5. I need units because this problem has units. What were the units for the length? Yep, so the units for the height are also going to be meters. Okay, so to recap, the idea on this problem is set up a proportion. And just going forward in general, because you know on the state test, they don't give you a study guide with the exact problems before you take it, right? You have to be able to just figure it out on the spur of the moment with no preparation. So going forward, if you see ratios in a problem, the minute they start talking about ratios, you need to start thinking proportions. Because typically that's how you find missing pieces of a ratio. Nathan, what are you doing? You on your phone? No. Question?
Since this is negative 16, positive 16, is it alright if we just put square root of 5 in? Or, yeah, 5 meters.
No, those are not like terms. If you had negative 16 plus 16x, would it be okay if you just put x?
Oh.
No, right? They have to be like terms, like radicals. Okay, working our way backwards.
You get with everything else, it's the only thing that don't matter.
I know, but the thing that concerns me, Nick, is the state test is jam-packed with word problems, right? Word problems are the real test of do you understand math. Not can you just remember the process that someone taught you, but do you actually know what's going on? Because that's what's required in order to do a word problem. And that's why students hate them, right? Okay, 16. Oh man, what happened to the time? I got to fly. What do I need to do on number 16?
You got to just simplify, see if you can simplify the
Yep, see if you can simplify anything. I know that I can't simplify the square root of 3 because 3 is prime. Can't simplify the square root of 5 because it's prime. 6 is composite, which means not prime. But its factors are 1, 2, and 1, 3, so I'm not going to be able to simplify it either. So I need to check 27, but it's the only one. It's the only one that could possibly be simplified. It's 3 times 9, 3 times 3, 3 is prime. Aha! It can be simplified. I need to pull out a 3, so I'm keeping all the rest the same. I'm going to pull out a 3 for this pair, times the negative 2 that was already there to get negative 6, and 3 goes back inside, because that's the thing I didn't circle. Copy down the rest. Am I finished at this point? What can I do? Yeah, these are like radicals, right? Negative 1 and negative 6, square roots of 3, gives me negative 7. Square root of 3, and the others stay the same. 15. Sorry, I'm going quick. I want to get as many as I can. 15, same deal. Actually, let's skip 15. I'll come back if I have time. Let's go to 14. Yeah, distribute, FOIL, right? First, 2 times no number on the outside is 2. 2 times 5 on the inside, 10. So there was my first. Outside, 2 times negative 5 is negative 10. Square root of 2 times no square root, still the square root of 2. Inside, negative 2 times the square root of 5 is negative 2 square root of 5. That's easy.
VZ.
Yes?
It should be 5, square root of 5 on the first one. On the first square root.
On this?
No, up top. Where it's 2 to the square root of 2, it should be 5.
Oh, I copied the problem down wrong. Thank you. You got it up for me. Good, because I would have definitely got the wrong answer. Okay, starting over, quickly. 2 times no square root, or 2 times no number outside is 2. Square root of 5 times square root of 5 is square root of 25. 2 times negative 5 is negative 10. Square root of 5 times no square roots, square root of 5. Negative 2 times square root of 5 is negative 2 square root of 5. Negative 2 times negative 5 is 10. Definitely know I can combine these, for sure. What else can I do?
25 can be factored.
I don't even have to factor it. 25 is a perfect square. What's the square root of 25? Alright, so this ends up being 2 times 5. These combine to be negative 12 square root of 5, and this is still a plus 10 for now. 2 times 5? 10. And now there are more like terms that have emerged. And so I end up with 20 minus 12 times the square root of 5. Questions? So just remember, if it's a binomial times a binomial, you FOIL. Make sure outside numbers get multiplied and inside numbers get multiplied, and then always be looking for something else to simplify.
Does it
Looking
matter?
critically every time.
Does it matter the order you list them in?
It does not. That's an excellent question. I don't care. No. Okay, 13. What am I doing on 13? Yeah, same thing I did on the last one, right? Distribute. Okay, so there's no number outside here times a negative 5 is still a negative 5. Square root of 5 times square root of 3, square root of 15. Then I got square root of 5 times square root of 10 when I distribute to that, and I get the square root of 50. Not finished because I need to try and simplify further. 15. I definitely can't simplify it because it just equals 3 times 5, right? There's no pairs. 50. That one I can though. 2 times 25, 5 times 5, 5's prime. So I have a pair of 5's. So this is staying the same. On this, I get to pull out a 5, and I'm putting back a 2. Questions about that? So Nick, I am documenting in this YouTube video that you've slept through much of my review. So if you have troubles tomorrow,
I already know how to do these. I'm not sleeping.
Okay.
I'm listening.
just resting your eyes, huh?
Yep.
Yep, that's what my stepdad says when he's sleeping.
No, like I'm really not sleeping. That's how I responded so fast.
What do I need to do on number 12?
I don't like super stressed.
Conjugate. Multiply by the conjugate. Get out.
I was sleeping like a brick.
So just remember, if you got a binomial on the bottom, and it's got a radical in it, it's going to take the conjugate to fix it. It's the only way. On the top, this is actually a pretty easy conjugate problem, really, when you get right down to it. On the top, 2 times 5 is 10. 2 times the square root of 5 is 2 times the square root of 5. On the bottom, we FOIL. 5 times 5, those are my first. It's 25. 5 times the square root of 5 is 5 times the square root of 5. Negative square root of 5 times 5 is negative 5 square root of 5. And then the last thing is negative square root of 5 times positive square root of 5, and that's negative square root of 25. Now I'm going to start simplifying a few things I know that I can. Like these go away, as they always should on these problems. And I end up with 10 plus 2 square root of 5, still on top. And then 25 minus, I know what the square root of 25 is, it's 5. Simplify the bottom, 25 minus 5 is 20. And then I can't forget the last step. This is the one, it's kind of new, and so some people are forgetting to do it. Remember, you have to check all your outside numbers and see if they're divisible by the same thing. Are they divisible by something? 2. So divide them all by 2. 10 divided by 2 would be 5. 2 divided by 2 would be 1, which I don't have to write. It's automatically there if I just write the square root of 5. And 20 divided by 2 is 10. So that would be my final answer. Questions on that problem? Okay. 11. Should have been super easy, because just for a little flashback to, I don't know, less than an hour ago, or roughly an hour ago. Look at the problem on the bell work. The square root part of it's exactly the same. The only difference is this one has a 2 on the bottom, and the problem on the thing has a 3 on the top. So we should have had no problems getting this one done, because I just worked one like it. So I would use the same strategy I used before. It was good before, it's still good. I would say, oh, 15 over 20. They're both underneath the radical, so I can simplify that part of the fraction and get 3 over 4, or rather square root of 3 over 4. And the square root of 4, I know what it is. It's 2. So I end up with 3 square root of 3 over 2, done. That's definitely the easiest way. It took me 2 steps. You could have done it a lot of ways. And I saw people do it different ways and get the right answer. So, and which is great. I applaud that. I'm not trying to tell you that you shouldn't. But make sure you're always trying to look for the easiest way, especially if you've got limited time, you know, in the same time. Questions about that? Or would anybody like to see a different way to work it? Okay.
I kind of corrected, but we had that on bell work. Did you get like square root of 3 over 4?
I did, because remember on the bell work it had a 2 on the bottom and no 3 on the top. So the 2 on the bottom got multiplied by this 2. 10. So I was impressed on 10 by you guys. Nobody freaked out when what happens on 10 happened to them. That just kept rolling along. That's good. I would factor 196 and m to the 4th. So this is 2 times 98, 2 times 49, 7 times 7, 7's prime, and then 4 m's. And I get to circle everything. And everybody realized what that means. That means the square root's going away. There's nothing's going back inside the square root. This is a perfect square. I get to pull out 2 times 4, which is 14. And I get to pull out m times m, which is m squared. And I'm done. And y'all did really good on that one. In fact, I meant to say before I started, but we're in pretty good shape on this stuff. Like walking around, everybody has 2 or 3 things, at least 2 or 3 things, that they've got. That they don't need to look over at all. They've got it. They know how to do it. So just find the things that you don't know how to do, and we'll do those. I'm going to skip 9 because I promise I didn't mean for this to happen, but look at the bell work. And look at 9. I mean, the first problem with the bell work is number 9, except it's got an R instead of an A. So you actually have the answer to number 9 already. So, all right. 8. I may skip around a little here too, depending on time, and try and hit the hardest one. This is definitely the harder of the 2 completing the square problems. Okay, so I got 2 options for my first step. Somebody tell me one of them.
Subtract 2 and 2.
that would be if I was factoring, I would circle the 7, but I'm completing the square here. So
Subtracting 2.
subtracting this 2 over here. Nope, that's not one of them.
Adding 2.
Adding 2, right? Remember with completing the square, you're trying to get the constants on the other side. It's the one technique for solving quadratic equations where we don't want to have a 0. We end up having to move the constants over. So adding 2 would be a good first step. What's the other possible first step?
Divide by 7.
Good, divide by 7. Those need to be steps 1 and 2 in some order, right? You can either add and then divide by 7 or divide by 7 and then add. I think it's probably easier to add the 2 and then divide by 7 on this problem, because if I divided by 7 here, both of these would be fractions. That's 2 fractions I got to deal with. If I wait and do it now, I'll only get 1 fraction. So I'm going to have to deal with 1 fraction. Okay, 7n squared divided by 7 is just n squared. 14n divided by 7 is 2n. And 4 over 7, unfortunately, is just 4 over 7. Nothing really I can do with that. So now I do that process where I find the number that completes the square. So I take half of the coefficient of the linear variable, so that would be this 2, and I square it. So half of 2 is 1. 1 squared gives me 1. 1 is the number that completes the square on this problem. So that's what I need to add to both sides. Okay, then I need to factor the left-hand side and combine like terms on the right-hand side. Remember, we have the shortcut for factoring this. What's the shortcut?
Put on 1 plus
Does anybody remember my little saying for the shortcut on how to factor it?
Root, sine, root.
Yep, square root, sine, square root. That's it. So, square root of the first term, sine from the second term, square root of the third term. And it's always 1 parentheses squared. And then over here, 4/7 and 1 is 11/7. Then I would take the square root of both sides. I'm doing that because I want to get rid of the squared. Remember, the goal is to get n by itself, and the squared is keeping that from happening. So the squared and the square root cancel, and I get n plus 1 equals plus or minus the square root of 11 over 7. At this point, that whole fraction is under the square root. I know it can't stay like that, because that means I have a square root of my denominator, which is not allowed. So I'm going to have to fix that eventually, but I'm going to wait till I get all the way to the end, and then I'll fix it. So I'm going to subtract 1. So n equals -1 plus or minus this ugly square root. Now I need to fix the ugly square root. So I'll do that over here. So here's what I've got. How can I fix it? Do what? Split them. Okay. And then what? Good. Multiply by square root of 7 over square root of 7. That's how you rationalize a denominator if it's a monomial, right? You just multiply by whatever it is you want to get rid of. What that does for me is square root of 7 times square root of 7 is square root of 49, but the square root of 49 is 7. So that square root of 7 times square root of 7 just turns into 7. And on top I get the square root of 77. Now, you might be tempted to try and factor 77 to see if you can pull anything out, but you should already know the answer to that question. Am I going to be able to pull anything out or not? Yeah, I know that because 11 is prime and 7 is prime. I multiplied 2 prime numbers to get this number, so that means it's not going to have any repeated factors, right? There's not going to be any pairs for me to circle. So I fixed it. So now that means that this is actually -1 plus or minus the square root of 77 over 7. And then I would split that up and get the decimals, right? So there's the exact answer. So you should end up with 0.254 for one of them and -2.254. Questions about that one? So just a quick recap. Remember, with completing the square, leading coefficient has to be 1. And it has to be 1 in either the first step or the second step. You got to do it immediately. You can't wait until you've done the taking half and squaring part, right? It's got to be done early. And there will be one on the test where you have to divide and one where you don't, just like on the study guide. I'll skip 7 for the time being, and I will go to 6, which is definitely the harder of the two quadratic formula problems. Good news is, at least it's equal to 0, so I don't have to worry about fixing that problem. A is 10, B is -2, C is -22, and it says to solve using the quadratic formula. So I'm going to plug into this. So that means I'm going to have negative B, which is going to be negative -2. So that turns it into 2. And then the square root of b squared is -2 squared minus 4 times a, which is 10, times c, which is -22, all over 2 times a, which is 10.
Which will equal 2 plus negative square root of 84.
Good, so when I evaluate this discriminant, I get 884 is the discriminant, and 2 times 10 is 20. And when we first learned the quadratic formula, this would be where we realized, oh, it doesn't work out nice and neat, and so this is my answer, right? But now we know how to simplify square roots, so you have to try and simplify the square root. This would be, you'd get most credit, right, for this, but not full credit. You would need to factor 884. It's 2 times 442, it's 2 times 221.
And 13 times 17.
Good, and it might take you a minute to find factors of 221. It took me a minute. But 13 times 17. Both those numbers are prime. 13 and 17 are both prime. Okay, so I do have a pair. So that means I get to pull out a 2, and I'm going to put back 13 times 17, but I already know what that is. It's 221. And that's all over 20. Still not done with my simplification, but this last step should be really easy. Check all the outside numbers to see if they're divisible by the same thing. They are divisible by 2, so divide them all by 2. And 2 divided by 2 is 1. This 2 divided by 2 is 1. I don't have to write that one. And 20 divided by 2 is 10. So now I've finally simplified it. So my exact answer would look like P equals 1 plus root 221 over 10. P equals 1 minus root 221 over 10. And then I would get decimals, which are P equals 1.587 and P equals -1.387. Questions about any of that? We're doing good, and lots of people got this far and then just didn't do these last 2 simplification steps. So just don't skip them. Don't give any points away. It's easy to do, right? If you can do it on the other pages, you can do it here. So, let's see. Let's skip to some factoring because we're almost out of time. 4 would be a good one. I'll do 4 and 3. I think those are probably the 2 hardest of the factoring ones. So 4. What do I need to do first on 4?
Add 5.
Good, yeah, in order to do the factoring, got to be equal to 0. It's not, but I can make it equal to 0 easily, right? Just add 5 to both sides, and now I've got that. Now I'm ready to go down the factoring checklist, so just hit it in order. Is there a GCF?
Yes.
Yes, what is it?
2.
Excellent. So I pull the 2 out, divide all these things by 2 to figure out what's left. 2a squared divided by 2 is a squared. 16a divided by 2 is 8a, and 14 divided by 2 is 7. Is there a difference in squares? No. Is there a quadratic trinomial? Yes. It's right here. So I need to t-chart it. Don't get fooled by the easy ones. I had a couple people who were like, I don't know what those numbers are. Sometimes it's so obvious that you miss it, right? That happens, so just be cognizant of that. Okay, so the 2 is hanging out. Just bring it down. And this gets factored into 2 parentheses, and the parentheses are a plus 1 and a plus 7. So I have 3 factors being multiplied to give me 0. 2, a plus 1, a plus 7. Those are 3 factors. can this factor, the factor 2, ever give me a 0? Can it ever be equal to 0? No, so it's not going to give me an answer. But these two things will. So I set them both equal to 0 and solve. So my answers are -1 and -7. Questions about that? Okay, we do trace. So we've got the same problem with number 3 that we had with number 4, which is it's not equal to 0. We know how to fix it. Yep. And we get 3x squared minus 17x plus 24 equals 0. Now that it's equal to 0, and since the instructions say to solve by factoring, I'm going to go through the checklist. Is there a GCF? No. Is it a difference of squares? No. Is it a quadratic trinomial? Yes.
Circle it, pull it away.
Good. So you have to remember that this one is different than the last one I factored, because the last one I factored had a leading coefficient of 1 on the quadratic trinomial part after I factored out the GCF. This became 1. And so it was easy. And this does not. It has a leading coefficient of 3, so I have to remember that AC method that we learned, where you circle the 3, and you pull it away, and multiply it times the constant, and you get, in this case, 72. And then I would find things that multiply to be 72 and add to be -17, so I know I'm looking at two negative numbers, right? For sure. It's the only way I get these signs to work out. Has anybody found the numbers?
-9,
-9 and -8 is perfect. -9 times -8 would be positive 72, and -9 plus -8 would be -17. Very good, Alec. So this factors to x minus 9 and x minus 8. You see I went back to erase so that I could put space, because I need to do what? Put 3 back. And then I have to check to see if there's any number that goes into 3 and 9 or 3 and 8, and simplify if I can. 3 and 9 both divisible by 3. So I get x minus 3 on this one. 3 and 8, no common factor I can divide by, so it stays the same. And now I just set each parentheses equal to 0 and solve. So x minus 3 equals 0 is going to give me one of my answers, and 3x minus 8 equals 0 will give me the other. I am. So one of my answers is x equals 3. And one of my answers is 8 over 3. Those are the two roots to this problem.
We've worked one other problem.
Questions about that? I want to work one more real quick just because there's a couple people struggling with it. I'll be done in time for y'all to put the calculators up, so don't worry. It's number 1. It's easy. But there were a couple people who had a hard time. This should be the easiest. It's got the easiest factoring in it. It's already equal to 0, so go down the checklist. Is there a GCF?
Yes.
Definitely. What is the GCF? 7x. The x is more important than the 7. So don't forget to pull out the 7 and the x. You write those, and then you put back the leftovers. 7x squared, take away 7x is just x. 21x divided by 7x is a 3. Please take the 10 seconds it takes to mentally distribute this and make sure you get your answer back. It will prevent you from making silly mistakes. And you set them equal to 0. So my answers are 0 for this one, and -3 for this one. Okay, you may put up your calculators and stuff.